Okay, folks, so before we were looking at the combined gas law, which was a before and after. So you always had a PI and a PF, and a VI and a VF, and a TI and a TF. Well, this is the ideal gas law, and an ideal gas law is actually a snapshot. So you're only going to have one of each thing: pressure, volume, moles, real gas constant, and temperature. Now, what is really critical in this is that you have to have exactly the right units, okay? So pressure has got to be in atmospheres. Volume has got to be in liters. Obviously, moles is moles. It always is. And temperature has got to be in Kelvin. And if that is the case, then the ideal gas constant R is going to be 0.0821. That is the only conditions under which you can use the ideal gas constant as 0.0821. Now, because you have 1,000 milliliters is equal to 1 liter, if you have milliliters, you need to divide by 1,000. And of course, you have to take Celsius and add 273 to get Kelvin. We're going to be using the same given unknown equation substitute solve that we did before. All right, so here we go. A sample of gas occupies 8.77 liters, 27 degrees Celsius. What is the pressure in atmospheres if there are 2.45 moles of gas in the sample? Report to one decimal place. All right, so you've only got one of each thing, right? So P, I don't know. That's atmospheres. V, I do know. That's 8.77 liters. N, I do know. There's 2.45 moles of gas. And T, I also know. That's 27.0 degrees Celsius, but you're going to have to add 273. So that is going to be 300 K. All right, so here are my givens. And then here is my unknown, right, for my G and my U. Then I'm going to have an equation. P times V is equal to nRT. Substitute and solve. Now check, make sure liters, yep, liters is fine. K is fine. All right, so P, don't know, times V, 8.77 liters, is equal to N, 2.45, times R, 0.0821 liter atmospheres over Kelvin moles, times T, 300 K. Now, algebra tells us if we want to get this all by itself, we have to divide by that. Yeah? Well, if you are going to divide the left side by 8.77, then you also need to divide the right side by 8.77. If you do that, then your 8.77s will cancel. You can put all of that in parentheses in your calculator, and we are going to get a pressure that we report to one decimal place. So, parentheses, 2.45 times 0.0821 times 300, close parentheses, divided by 8.77 is equal to, and then I get 6.88067. I want one decimal place, which is going to be that decimal place. Because the number behind it is 8, that is going to be rounded up to 9. That is going to be 6.9 atmospheres. All right, next. A gas is measured at 1.5 atmospheres of pressure, has a volume of 1,750 milliliters when measured at 295 K. How many moles of gas are there? Report to two decimal places. All right, so our P is 1.5 atmospheres. Our V is 1,750 milliliters. But remember, our V has to be in liters, so we're going to need to divide by 1,000. So we're going to divide that by 1,000 milliliters per liter. Milliliters cancel, and I'm going to end up with 1.750 liters. Or I would have moved the decimal 1, 2, 3 places. All right, PV is equal to N. N, we do not know, but it's in moles. T is 295 K, so we're good to go. All right, so PV is equal to N RT. So pressure, 1.5 atmospheres times V, 1.75 liters, is equal to N, don't know, times 0.0821 times T, 295. All right, now just to make this easier on myself, I'm going to go ahead and I'm going to group these two and turn them into a single number and rewrite the thing. So I'm going to leave the left-hand side the same. 1.5 times 1.75 is equal to N times. Now I'm going to take my 0.0821 times 295. 24.2195. I'm going to leave myself plenty of decimal places. Now, algebra tells us, again, if I want to get rid of this, I've got to divide by 24.2195. So, divide by 24.2195. That allows us to cancel that, becomes 1. Anything I do to the right, I also need to do to the left, 24.2195. And so my moles is going to be parentheses 1.5 times times 1.75, close parentheses, divided by 24.2195, and that's going to be 0.10838. I want to have two decimal places. This is my second decimal place. I look at the number behind it. It is bigger than 5. So I'm going to round this up, and it's going to end up being 0.11 moles. There you go, folks. That is how you solve ideal gas questions.